3.5 notes, transformations of functions. This is page 2. So again, we are going to start off with the parent function here. We are graphing on examples 3 and 4, the absolute value function, which we talked about earlier in chapter 3. We saw that this was defined as a piecewise function. So here's our parent function. F of x equals absolute value of x, where the slope is negative to the left of 0, it's positive to the right. First thing we are going to do is go ahead and go back to our horizontal translations. We've got f of x equals the absolute value of x minus 3, just like we talked about on the first page. That can be rewritten as x minus h, then our h is 3, and that moves our entire graph 3 to the right. Again, it's helpful to focus on that anchor point, that 0, 0, figure out where that moves, and then you are good to go. So the next one here, g of x equals the negative absolute value of x minus 3. We have not talked about yet, but we're taking our output value and we are making it negative. So what that is going to do, sorry, my purple graph was off a little bit, my purple highlighting, is that is going to reflect this over the x-axis. It's going to be that same absolute function value, just flipped upside down. Next one we are looking at is our h of x. Again, here we have it written as the absolute value of x plus 2. We want this as x minus h, so I can rewrite that as x minus negative 2. That moves that anchor point, that 0, 0, 2 to the left. So now my vertex is at that point, negative 2, 0. Whole thing is moved 2 units to the left. And there it is. Last one here. I'm going to put this in orange after I highlight that one. K of x equals negative x plus 2. Notice here the negative is attached to the x. It's not out in front. So let's look at this another way. I'm going to factor that negative out of both pieces. This minus 2 part now moves it 2 to the right. And then this gets reflected over its center axis. And so here, because we are talking about graphing an absolute value, that reflection over the center axis doesn't change it a whole lot. It swaps that left-hand side with that right-hand side, but they lie right on top of each other. But that negative is going to reflect over the x, so over our center axis. Here we've already moved that 2 to the right with the x minus 2 part. So then as it reflects over that, just lies right on top of itself. Next thing we want to make sure we can do is determine whether a function is even, odd, or neither. So an even function, if we take a look up above, our absolute value function is an even function. An even function reflects across the y-axis. So if we have a picture of it, it's pretty easy to determine whether or not it's even. Not quite as straightforward if we're looking at this algebraically, but we are going to focus on this statement right here. We know it's even if f of negative x equals f of x. That means if I substitute in negative x, I'm going to get the exact same thing as if I substitute in positive x. So let's go down to 5a and take a look at this. First thing we're going to do is we are going to plug in negative x. So I get negative x quantity squared plus 6. Negative x squared is the same as positive x squared, so I get positive x squared plus 6, which is what my original function value was. So this is even. So you can change up colors a little bit. Next thing we want to check for is if a function is odd. So an odd function looks like a 180-degree rotation about the origin. Okay, so it's symmetric about the origin. That means that the origin will always lie on an odd function. Here's what it looks like algebraically. If we plug in negative x, we get out negative y. So you know what? I'm going to add this little note here. The origin always lies on an odd function. So let's take a look at b. I am going to plug in negative x. I get 7 times negative x to the third minus negative x, which gives me negative 7x to the third plus x, which is the exact opposite of what we started with. So this one's odd. Okay, the sign on everything must change. And so let's take a look at C and D and see what happens here. I am going to plug in negative x. I got negative x to the fifth plus 1, which gives me negative x to the fifth plus 1, which doesn't equal h of x. It's not exactly the same. It does not equal negative h of x. Because all of the signs haven't changed. So this is neither. It's not an either or situation. It's not that every single function has to be even or odd. It could be even. And then we've got some nice symmetry properties. It could be odd, and then we have different symmetry properties. It could also be that it is neither of those. So take a minute, give D a try. You are welcome to hit pause and then come back. And we are going to do the same thing. We are plugging negative x in. I got negative x to the third, negative x to the second, minus 4 times negative x plus 2. I get negative x to the third, plus x to the second, plus 4x plus 2. Notice that the signs changed in 2 places. But it did not in 2 places. So this one's also neither.